Today we're going to learn another method that always works when finding the roots of quadratics. So once again, factoring works some of the time, but most of the time it doesn't. And then completing the square always works, but it's a little confusing. There are a lot of steps that you need to remember, and we found another way to solve those. And we call it the quadratic formula. Now the quadratic formula is based on this quadratic. ax squared plus bx plus c. This quadratic represents every possible quadratic. A could be any number, including 0. B could be any number, including 0. And C could be any number. So every single possible quadratic is represented by that function, where A, B, and C could be any real number. Okay? And what we do is complete the square. So instead of completing the square every time you want to solve a quadratic, we write a quadratic that represents every possible quadratic, and then we complete the square. The trouble is, when A is not 1, completing the square is really complicated. So I'm not going to show you how to do this because it's a long process and it's not going to do you any good. You won't have to recreate it. But trust me, when you move the c over and you cut the b in half and take the square root, add both sides, all of that stuff, you end up with this equation. X equals negative b plus or minus the square root of b squared minus 4ac over 2a. And that formula will solve any quadratic, whether it has nice roots or not nice roots. Okay, and you will be using this, and I'll help you with memorizing it in just a little bit. But what this is saying is, if I had the quadratic 5x squared minus 6x plus 2, all I have to do to find the roots is take the 5 and enter it here and here. And then I take the negative 6 and I enter it here and here. And then I take the 2 and I enter it right there. And that will solve the equation for me. And essentially, it's completing the square. But instead of completing the square on every separate equation, we completed the square once on an equation that represented all of them. And then all we have to do is plug the numbers into the formula. Now, a couple things you need to know. A is always the x squared term. Even if your quadratic is out of order, A is always the x squared term. So I recommend when you look at a quadratic, you put it in the correct order. B is always the x term, and C is always the constant. All right, let's get rid of this stuff. Let's start with something simple. X squared minus 6x plus 5. What is A in this case? 1. The number in front of the x squared is a 1. And B? Negative 6. And C is 5. So I plug those in. The instructions in the equation says take the opposite of B. What is the opposite of B? 6 plus or minus. And then I recommend that instead of writing B to the second, you just square it. What is negative 6 to the second? 36. So I would never write this because chances are you're going to mess that up when you put it in your calculator. Because if you type in negative 6 squared, you get negative 36. So instead of writing that, I recommend you just square it. So negative 6 times negative 6 is 36. And then off to the side, I would write negative 4 times the A term times the C term. So it would be negative 4 times A, which is 1, times C, which is 5. Negative 4 times 1 times 5 is negative 20. And that's how I recommend you solve this. Write the b squared term, square it, and write what it actually equals. And then off to the side, perform this calculation. And whatever you get there, put it next to the b squared term. All divided by, what is 2 times a? 2. A is 1. Okay, now we simplify the square root. What is 36 minus 20? So this is the square root of 16. What is the square root of 16? 4. 6 plus or minus 4 over 2. How do we solve that? Six plus 4 would be 10 divided by 2 is 5. 6 minus 4 is 2 divided by 2 is 1. Does that make sense? Okay, let's try another one. What should I write down? The opposite of b, actually let's make this positive 7. The opposite of b is negative 7 plus or minus. What is b squared? 49. And now I need to do negative 4 times 1 times negative 8. What is negative 4 times 1 times negative 8? Positive 32. So I add 32. All over 2 times 1 is 2. Okay. 49 plus 32 is 81. What is the square root of 81? 9. Negative 7 plus or minus, oh wow. Negative 7 plus or minus 9 over 2. Negative 7 plus 9 is 2. Divided by 2 is 1. Negative 7 minus 9 is negative 16 divided by 2 is negative 8. Okay? Everybody okay with that? All right. What about this one? Well, negative 6 plus or minus, what is b squared? 36. And then negative 4 times 2 times negative 4. Negative 4 times 2 is negative 8 times negative 4 is 32. +36 32 is 68. Oh my goodness, I'm sorry. It's over 4. I'm glad you guys are paying attention. Yep. 2a in this case is 4. All right. Well, negative 6 plus or minus, this ends up being the square root of 68. And all I really want is the decimal. Okay, I'm not going to make you guys find the square root answer. All I truly want is just the decimal. So I'm going to do negative 6 plus the square root of 68. Negative 6 plus the square root of 68. And what do I do with that number? So I push enter. And I divide that by 4. And I get x equals 0.56. Okay. And then negative 6 minus the square root of 68. And I push enter. And then divide that by 4. And I get x equals negative 3.56. Does that make sense? Okay. And once again, this formula will always work. It doesn't matter what your quadratic is. It will give you the roots. Interestingly enough, Even if the quadratic misses the x-axis, this will tell you where the roots are. If you have this graph, it appears as though that doesn't have any answers, but it actually does, which is kind of weird. We'll deal with that in the next section. You don't have to worry about that today, but every quadratic, whether or not it hits the x-axis, has roots. Some of the roots just aren't real. They're imaginary roots. And imaginary doesn't mean pretend. It just means they're not real numbers. All right. So I want you to do in 4.5, 3 through 21 odd. Oh, wait a minute. Gonna get that. Okay. Okay, hold on, that's not what I want. I want you to do I want you to do 3 through 22 all, but skip. No, never mind. Don't skip anything. What happens if I have this? Let's say I have x squared plus x plus 9. Well, I'm going to plug these into the equation. -1 plus or minus the square root of 1 minus 4 times 1 times, it's got to be plus 9, times 9 is minus 36 over 2. Okay, this is quite important because this will happen to you today. So, what is 1 minus 36? Negative 35. I have -1 plus or minus the square root of negative 35 over 2. So I try to type that in my calculator. -1 plus the square root of negative 35, and I hit enter, and I get error. Why? You cannot have a negative underneath a square root. So this does not mean no solution, because I just told you that every quadratic does have two solutions. What this means is this particular quadratic misses the x-axis, and we don't know how to solve that yet. So if you get to a problem where you end up with a negative underneath the square root, you need to write no real solutions. So if you solve and you get a quadratic, you get an answer of the quadratic where the square root has a negative in it, you just write no real solutions, and that will happen a couple times in this assignment. Okay, and then in the next assignment I will teach you, in a later assignment I'll teach you how to find those. So your problem set today is 3 through 22 all, and you need to use that quadratic formula.